Alright, here's part 2 of our medium questions for a sysadmin in a job interview using opensource.com as our reference. The next question we were on is pretty straightforward, so explain the boot process for Linux. Alright, so first the BIOS goes to the master boot record, then uses something called grub, which gets the kernel loaded, and then an initiation happens, and now you're at the run level. I am just not too sure about this particular question or how they want it answered, how you would sit in a job interview and say these things. I could go on and on about the master boot record, but I'm not sure what they're looking for. So let's skip that, and now we're going to go to how do you check the error messages while the server is booting up. You could tell the people on the interview panel that kernel messages are always stored in the kmesg buffer. It's visible via the dmesg command. Boot issues and errors call for a system administrator to look into certain important files in conjunction with particular commands, which are each handled differently by versions of Linux. Okay, so let's ask the question, what are important files? And it looks like we're about to read that. The boot.log, which can be found in the log folder, which is in the var folder. This is the system boot log, which contains all that unfolded during the system boot. Another thing to look at is messages in that same folder. Messages stores the global system messages, including the messages logged during system boot. What would be the difference between these two? And our last one, dmesg, contains kernel ring buffer information. Not sure why you want to look at that while there's a boot problem, that is. But let's ask that question. What can dmesg show you? If you go back to the very top, it shows you what's in the kmesg buffer, which is kernel messages. Maybe you could do a Google search on Linux boot up problems. Alright, let's get to question 11. What is the difference between a symbolic link and a hard link? I remember the author of the article wrote this in July, but here's an update as of August 30th. Apparently the original said a hard link is a mirror copy of the original file, which is not accurate. So what is a hard link? Let's start with that, because we know what it's not. It's not a mirror copy of a file. A hard link is a directory reference to the same inode that the first directory entry refers to. And the inode is updated to increase the reference count to know there is a new link to the data. This means that when a file is deleted, the directory is updated to remove the file name, and the inode for the data has the reference count decremented. Just wanted to search inode in Linux real quick. An inode contains information, like metadata, about a regular file and directory. So just remember inode is metadata, and this could be either about files or directories. So how does a hard link relate to this? Well, let's just focus right here where it says a hard link is a directory reference to the same inode. Sounds like it preserves the metadata that is in an inode. This part gets kind of confusing because he says soft links create a way for a directory entry to say the file information is really stored in another directory entry. Soft links break if another directory entry is deleted. So basically, soft links get deleted when the entry is deleted. I feel like we're in a computer forensics field right here. Let's read the last paragraph though for this question. He says that a way to describe the difference between a hard and soft link is that a hard link is a link to the file data, and a soft link is a link to another file name. So confusing. But if we go up here, is he saying that a symbolic link is another name for soft link? I mean, when I type in the question, it looks like the answer is yes to that. So let's put that in the back of our mind to research later, because I'm pretty unsatisfied with the question and answer they provided here. It's okay though, opensource.com. I still really appreciate all the resources you give. Next up, number 12. How do you change kernel parameters? What kernel options might you need to tune? To set the kernel parameters in Unix-like systems, first edit the file etc syscontrol or cdl.conf for configure. After making the changes, save the file and run the system control tacp command, and this command makes the changes permanent without rebooting the machine. So I like the question, how do you change kernel parameters without rebooting the machine? And the answer is basically this. You would go to this file, make the changes, save the file, and then run this command. So that's pretty straightforward, and if you're on a Linux system right now, you should go ahead and experiment with that. Well, make sure you're experimenting in a virtual machine just in case something goes wrong. Next question, explain the Proc file system. Well, the Proc file system is virtual and provides detailed information about the kernel, hardware, and running processes. Since Proc contains virtual files, it is called the virtual file system. And these virtual files have unique qualities. Most of them are listed as 0 bytes in size. Now, virtual files such as proc interrupts or meminfo, mounts, and partitions, they provide an up-to-the-moment glimpse of the system's hardware. Others, such as file systems and sys directory, provide system configuration information and interfaces. How about I just ask this? What can you find in the proc directory? And you can say things like virtual files, such as interrupts, memory information, mounts, partitions. You can also say you would find information about the system hardware and configuration information, plus the interfaces of the system that you're on. Alright, so number 14 is how do you run a script as another user without their password? Okay, so say you are editing the sudoers file. Here's an example of the file. You might use a command called visudo, vi sudo, to add the following. So user1, you're going to put all equals user2, no password, colon, and then here's the command you're running. You typed out the commands and saved it in a file called generate.sh. So here, what I've highlighted is the key to answering that question correctly, a question about what to do without a password. But let's not put the technical detail there. Let's put maybe a higher level kind of idea. How about this? Why would you want to run a command as another user? In what scenario would you want to do that in? And finally, for our last question in the medium question category, what is the UID 0 Tor account? Look at that word root written backwards. Follow-up question, have you been compromised? Well, the Tor user is an alternative super user account where Tor is root spelled backwards. It is intended to be used with a non-standard shell, so the default shell for root does not need to change. Alright, so it's a non-standard shell. Now the purpose is important. Shells which are not part of the base distribution are instead installed from ports or packages, and they are installed in your user local binary folder, which by default resides on a different file system. So if root's shell is located in this location, and the file system containing that location is not mounted, root could not log in to fix a problem, and the sysadmin would have to reboot into single user mode to enter the shell's path. So similar to before, I'm asking a question that's a little higher level than this one, a little less technical. The question is, why is a non-standard shell helpful to a sysadmin? And I can't answer that because I'm focusing just on this article, but you can do your own research or look for videos from me in the future answering these two questions.